Okay, so the discriminant is part of our quadratic formula. It's actually just b squared minus 4 times a times c. So again, this would be the part that would be underneath the radical. So we're really just looking at this part underneath here. So our discriminant itself is b squared minus 4 times a times c. And with that, we can actually determine what type of answers we're going to get when we use the quadratic formula. It's also going to tell us what type of answers this quadratic specifically has. So if we have a d, or a discriminant greater than 0, and it is a perfect square, so again, our perfect squares would be like 1, 4, 9, 16, any of those. We know we're going to get 2 roots, so the number of roots in this case would be 2. And the type of roots are both going to be either integers or we're going to say rational roots, meaning that they can be represented as a fraction. Okay. If we have a determinant or a discriminant, I think it is determinant, greater than 0, then we're going to still have 2 roots, but these would be numbers that are not perfect squares. So in this case, we have like 2, 3, 5, 7. All of these numbers are not perfect squares. And that means we're going to have an irrational number, or 2 irrational numbers as our solutions. So again, we can think of a rational number as 1, or you think it as like 3/4. Irrational number means we're going to have that square root sign still part of it. So you could have like the square root of 3, or the square root of 7. Okay. You can say plus or minus. If our discriminant equals 0, that means we're going to have one solution. So one solution, and it's just going to be a rational as well. Again, rational number can be an integer, it can be a fraction, something. Okay. And the last one, if d is less than 0, we're going to have 2 answers again, but they're both going to be imaginary numbers. So again, that means we're going to have an I involved. Okay. So that's kind of the outcome whenever we plug in these numbers from our quadratic. Right? When we plug in b squared minus 4 times a times c, we've got 4 possible outcomes. If our discriminant is a perfect square, we're going to have 2 rational numbers. If d is greater than 0 and it's not a perfect square, we're going to have 2 irrational numbers. If d equals 0, meaning all the numbers underneath the radical disappear, we're going to have 1 rational number, because that whole part's going to be gone. And if d is less than 0, that means we're going to have 2 imaginary numbers. Because again, that's going to be a negative underneath a radical, and anytime we have that negative under the radical, it becomes imaginary. Okay. So let's look at a couple examples, just 1, 3, 4. So number 1, we've got 2x squared minus 12x, or plus 12x minus 13 equals 0. So again, all we're doing is we're plugging in b squared. So b squared would be 12 squared minus 4 times our a, which is 2, times our c, which is negative 13. And we want to multiply and combine all of this down. Well, 12 squared gives me 144. We have 4 times 2, or negative 4 times 2 gets us a negative 8. Times a negative 13. So 8 times 13 is going to give us a positive 104. Add our two numbers together, so 144 plus 104 is going to give us a 248. And I do not believe 248 is a perfect square. It could be. It is not. Okay, so 248 is not a perfect square. So in this case, we have this second option, right? Our discriminant is greater than 0. We're going to have two solutions. And they're both irrational. Okay, so again, all the discriminant is telling us is how many solutions we're going to get and whether they're going to be irrational, rational, or imaginary. Okay.
So on the test, we'll have to write two solutions in a rational thing?
Yeah, just say two solutions, irrational. So let's look at number 2. Negative x squared plus 16x minus 64 equals 0. So again, b squared, so 16 squared minus 4 times our a times our c. We want to combine all those together. 16 squared gets us 256. We have 3 negatives, so I know my final answer when I multiply those is going to be negative. So we have negative 4 times negative 1 gives us a positive 4 times a negative 64 is 256. So in this case, 256 minus 256 gets me 0. And that's going to get us 1 rational solution. And again, that means if we only have one solution, we're dealing with a quadratic, which is U-shaped. That means our vertex is on that x-axis. Okay. Number 3, negative 4x squared plus 84 equals 10x. So the first thing we have to do is we want to set it equal to 0, so we need to move our 10x to the left side. So we subtract 10x over negative 4x squared minus 10x plus 84 equals 0. So again, b squared, so negative 10 squared minus 4 times our a, it's negative 4 times our c, just positive 84. 10 squared is 100. I know I'm going to add this to it. So we have 4 times 4 gets us 16 times an 84. Gives us 1,344 plus 100. We're going to take the square root of 1,444, and that gives us 38. So in this case, 1,444 is a perfect square. Right? I was just checking, we do get 38, which means we're going to have 2 rational solutions. Okay. So again, we don't really have to take that square root. I just wanted to check and make sure it was a perfect square. And when I did that, I got 38, so it was a true perfect square. And that tells me that I've got 2 rational solutions. And then our last one, number 4. 3x squared plus 24 equals 0. So again, b squared, in this case, my b is non-existent, so that's just 0 minus 4 times our a, which is 3, times our c, which is 24. So we have 0 squared, just disappears. 4 times 3 gets us a negative 12 times a 24, 288, negative 288. So again, this is a negative number, so we're going to have two imaginary solutions. Meaning our quadratic is either above the x-axis opening up or it's below the x-axis opening down. So we never cross that x-axis. We don't have any real solutions to that quadratic. So that's what our discriminant tells us. Again, tells us how many solutions we're going to have when we graph it, how many x-intercepts we're going to have.